Hello everyone, welcome to your next class. So in the previous sessions we were dealing on the chapter 11, that is pointers. So we have started to know about pointers. Till now we had studied how the pointers is used. What do you mean by the pointer? How we can declare the pointer, how we can define the pointer, and we had also seen how a pointer variable can be assigned to the other variable. With that, we had seen the different advantages of the pointer variables. We had seen the different advantages of the pointer variables. So these many points we had covered from this chapter, and all the points are important for your final theory exam. All the points are important for your final theory exams, where the meaning of the pointer can be asked for 1 marks, the declaration separately can be asked for 1 marks, the defining of a pointer variable can be asked for 1 marks, both combined defining and declaration can be asked for 3 marks, the initialization of a value, that is a value assignment to a pointer variable, can be asked for 1 marks and 3 marks. And the next, the advantages of the pointers can be asked for 3 marks. So these questions already has been asked in the previous years for the theory exam. For that purpose, these all are important questions you have to consider. Write the notes properly for your these 3 values. So in the last session, I was dealing about how you can initialize a value to your pointer, and we had seen the advantages of the pointers. We'll just do a little bit revision on this, and today we'll see the next part on that. So we have the different advantages of the pointers. So which are the pointer advantages we have? The first one advantage we have is the pointers save the memory space. The pointers saves the memory space. So how the pointers are saved the memory space is because it stores the addresses of the memory so that no other variables are required to store again these values. We can do it with the pointers on. If you want to perform any operations on those addresses, no need to use any different other variables. We just can use these variables and we can perform these values. And so the second one we have is memory is utilized properly. The memory is utilized properly. So using the pointers variables, we can make the use of the memory properly without any wasting. How the memory is utilized properly? Because we have another advantage of using your pointer variable, that is the dynamic allocation and deallocation of the memory is possible using your pointers. So I had told you what do you mean by dynamic allocation and what do you mean by static allocation. If you declare your array at the time of before the use of your program, means before that usage of the variable in the code, in declaration section if you declare and the same is assigned at the time of the execution, then we can feel 2 problems. One is, suppose you have declared a variable that is an array size as 10, and at the time of the execution you want to enter 20 elements into that array. That is not possible because the array size is only 10. 10 more variable which you want to store in your array, that leads for the memory, less space of the memory. That leads the problem of less space of the memory. Next, one more problem you can face is if your array size is 10 and at the time of the execution you are storing only 3 elements, then the other 7 memory are wastage. Those are the extra. You cannot release them also. Those will be the only act like a wastage of the memory. Right? So these 2 problems we feel when you declare the variables at the time of the static allocation. If the same you follow for the dynamic allocation, then that can be resolved. What you can do is, you can declare the variable size as 10, 20, how much you want, but at the time of runtime, means at the time of the execution, how many elements you are storing, only that much of the capacity is used. Suppose, same example you can take it. I had declared an array called as Z with a size 10. Now I want to enter the elements, 15 elements. Declared size is 10, but the elements I want to enter are 15, so 5 or less, I want 5 more blocks of the memory. If I declare it dynamically, then automatically the memory space is increased. No need to tell the compiler, no need to instruct the compiler, not a question of facing the problem only. Okay, next, the second one. If I declare the memory space as 10 and I'm using only 4 blocks of the memory at the time of the execution, then the other 6 will be released and can be used by other variables if you declare it dynamically. Then, so the static memory allocation, which problem we were facing, can be solved using the pointers if you are using dynamic method of allocation and deallocation. That was the another advantage of your pointers usage. The next one we have is easy to deal with your hardware components, because we know that when all we have to deal with the hardware, we have to deal with the machine language, and the addresses of the memory is saved in the format of machine language only. So rather than converting them into the user format and then the machine language, we better prefer of using the pointers so that we directly can operate on, communicate with your hardware components. Next, coming to the next advantage we have is establish communication between program and data. Pointers are used for file handling. Pointers are used to create complex data structure such as your linked list, stacks, and queues and trees. So these all are the advantages which are used in advantages when we use the pointers. Then the next point we had also covered is how we can initialize a pointer variable. We had also seen how we can initialize a pointer variable, that is pointer variable assignment we had seen. Then, so pointer variable assignment, how we can do it. Then, for example, a common syntax you can take it is one pointer variable equals to ampersand of that variable's addresses. If you write this much is more than enough. So how this is written? The very first thing is you have to declare a variable, then you have to declare a pointer variable, and then you can assign this variable. Both the pointer variable and the variable which you are using should be of same type. Means the num is of integer, then the IPTR is also should be the integer type. If num is of char, IPTR should also be of char. If num is of float, IPTR is also should be of float. If num is integer and IPTR is of char, it is not possible to store the address of num into your IPTR, because IPTR is of character and num is of integer and both are of different data types. Then we can store a address of a variable in your pointer variable of when both are of same data type. That condition you have to remember. So how we can initialize backgroundly? First you have to declare both the variables. So int num, int asterisk IPTR, and then you can write the statement IPTR is equals to ampersand of num. Then, so this is how we initialize a pointer variable. Right? So yesterday we had covered this much. Now we'll move to the next point in your chapter. Those are the operators used in your pointers. Which all the symbols or which all the operators we use in your pointers. So there are mainly two operators or two symbols we use in your pointers. This question also comes for 1 marks or 3 marks. Right? So you have to study it and understand these points neatly. So the first operators we use in your pointers are the address of operator. The first we use is the address of operator. So what is the symbol of address of operator? We had studied already, that is the ampersand symbol, because the ampersand symbol is used to mean with your addresses. So when we want to direct or when you want to deal with the addresses of the variables, we use this ampersand symbol. So this is called as address of operator. Then, so here this ampersand is an unary operator. This ampersand is an unary operator. So you know the meaning of unary operator, binary operator and ternary operator. Unary operator means the operator which is performing on only one single operand. That operator is called as unary operator. Binary operator means an operator can perform on operations on two different operands or same operand, but there should be two operands. And ternary means more than two operands. Such operators are called as unary, binary and ternary. So here this address of operator, that is your ampersand operator, is an example of your unary operator, and it returns always the memory address of its operand. It returns what it returns? It returns the memory address of its operand. Underline this point. So what is the use of your ampersand operator, or what is the use of your address of operator? It always returns the memory address of its operand. Its operand means this operator with which operand you are using, or with which variable you are using, that variable's address it will return. So here we have written ampersand num. Ampersand is your address operator and num will act like an operand now. Num is a variable, right now it will act like an operand. So this address of operator will return the address of num. The address of num. That is, what is the use of your address of operator? So address of operator is nothing but your ampersand operator. It is a unary operator, and what is the use of it? Is it returns the memory address of its operand. So with which variable you use, that variable will act like an operand, and it is used to get address of that variable. Remember it for 1 marks. Here only we got 2 questions for 1 marks. So which is the address of operator? Is you have to write your ampersand operator. Then, so what is the use of your address of operator? Is it is used to return the memory address of its operand. Right? So like this. So in this chapter, which all, at every point you have to study, whichever point can be asked for 1 mark. Then, so when all it is you feels it is important, if it is assigning to any values, declaring, defining, or the usage, every point you have to study it in detail, because it carries for 1 marks. Then, so yeah, what it returns, the address of operator, it returns the memory address of its operands. Next, consider an example as I told here. If n is a variable, and I write ampersand of n. If I write ampersand of n means it returns, this ampersand symbol returns the address of n. The address of n. Then next, we should read how you have to call this ampersand symbol. How you have to call, or how you have to read this ampersand of symbol. You have to read this ampersand of symbol as the address of operator. You have to call it as the address of operator. How you have to call this ampersand symbol? You are not allowed to read it as ampersand symbol in the pointers chapter. If it is dealing with pointers chapter, if it is dealing with the address of any variable, then you are not allowed to read it as ampersand. Now onwards, what you have to read it as? The address of operator, you have to read it. And if suppose you are written, consider this example, ampersand of n, then what, how you have to read it? The address of n. You have to read it as the address of n. You are not allowed to read it as ampersand of n. You have to read it as the address of n. Then, so this ampersand symbol, when you are dealing with the pointers chapter, you have to read it as the address of operator. And when it is with the variable, how you have to read is the address of the n. The address of the n. In that way, you have to read it. Right? So we'll consider one example for this of the address of operator. So how we can write the example? Same which we had written, in the same way you have to write how we had written for the initialization. Then, so the example you can write int z is equals to 30. So we have a variable of integer type z, and to this one value has been assigned, that is 30. Done. Now as we are dealing with the pointers, the pointer variable has to be declared int star ptr. Int star ptr. A pointer variable has been declared. Now we have to store address of z in ptr. So how to write that line? Ptr is equals to address operator, don't read it as ampersand, the address operator and the variable z. Done. So now here we have used the address of operator. The address of operator, your operator symbol, you have to write it. So here the address of z is stored in your ptr pointer. How to read it as? The address of z is stored in your ptr pointer. Then what is the use of your address of operator, what it is called, and when it is used? There is an operator we use in your pointer is your ampersand operator. It is called as the address of operator. It is a unary operator and it returns the memory address of its operand. This symbol is used with which are the variables. Those variables are called as the operand for that moment. Done. So example, n is a variable, the symbol ampersand symbol and n. Now it is called as the address of n. Done. So this ampersand symbol is called, read as the address of operator, the address of n. Like that you have to read it. Now how we can use in the program? Int z is initialized to 30. Int star ptr means the ptr is a pointer. Now the address of z is assigned to your ptr variable, that is to pointer variable. So the address of z is stored in your ptr. Done. So this is the first operator used in your pointer, that is address of operator. Right? So we have another operator in the pointer which is used when we are dealing with the pointer concept, that is called as pointer operator or indirection operator. The another operator we have is pointer operator or indirection operator. And what is the symbol of that? Is your asterisk. There are mainly two operators we use in pointers. One is ampersand symbol and another one is your asterisk symbol. The ampersand symbol is used like the address of operator, and here your asterisk, that is your star symbol, is used like a pointer operator or indirection operator. This is read in two ways. Two names we have for this asterisk symbol operator or your star symbol. One is a pointer operator and another one is indirection operator. Okay? Here. Yeah, second operator which is named as indirection operator, that is your star, and it is complement of your ampersand operator. It is the complement of your address of operator. So for what purpose we use this indirection operator is, this is used means it returns the value of the variable located. It returns the value of the variable which is located at the address of specified by its operand. At the address of specified by its operand. Now I'll write the meaning and how it is worked. We'll trace it in the program. Right? So this is also one unary operator. This is also one unary operator, and what it returns is, it returns the value of the variable, located at the address specified by its operand, specified by its operand. So your address of operator returns the address of the variable of its operand, and this pointer variable or indirection variable returns the value of the variable located at the address specified by its operand. Right? So how it is worked and all we'll see in the programming example. First, let me write how we use this indirection program. Only in 3 lines I can just tell you. The example we'll just see it. Variable we have to declare int num is equals to 40. Int asterisk p. Now this asterisk p is your pointer operator. What we have used here to define this variable as a pointer, no? So it is nothing but a pointer variable. It is nothing but a pointer variable or pointer operator, which is also called as indirection operator. There are two names, pointer operator and indirection operator. And after this we can write p is equals to ampersand of num. So this is your address of operator, this is your pointer operator, which is also called as your indirection operator. Done? So understand the meaning, which is your pointer operator, this asterisk, which is also called as indirection operator. So don't get confused. Suppose in your exam, if they ask pointer operator, they are meaning with the same symbol. If they ask indirection operator, means they are referring for same symbol. Then, so this pointer is the complement of this address operator. Is complement of this address operator. This is also a unary operator. And what it returns? It returns the value of the variable which is located at the address of specified by its operand. Right? So when we use it in the program, that time I'll tell you what is the exact purpose of using this indirect operator. Next, this is called as your pointer variable or the indirect variable. Right? So now I'll write a small program. And we'll see how we can use exactly your address of operator and the pointer operator in the program. Done? So we'll use this one program, small program we'll write, and we'll see the usage of both address of operator and the pointer operator. Done? A program to illustrate pointer variables, pointer operators, not the variables, pointer operators. A program we are writing to illustrate your pointer operators. Right? So I'm not using your objects and classes, a simple program I'm writing. In lab program we'll do that all the works. Right now we just have to see the usage and how it works in the program. Both the operators, that is your address of operator and pointer operator. So I'll write the simple program. Then, so let me write first the header files. Hash include iostream.h, hash include conio.h, hash include iomanip.h. So these are the three variables we had used, three header files we had used. Hash include iostream.h, conio.h and iomanip.h. So I am not using the classes and objects. So let me write directly void main and void main. Open the body of your main function. Now which are the variables we want to use? Those all the variables we write it. Right? So I have to use a variable, a normal variable and a pointer variable. A normal variable and a pointer variable. Done? So we'll go now. First declaration is done. Int n. Int n. A variable has been declared. Next, we want a pointer. What we want? We want a pointer. So int, as the variable n is of integer, the pointer should also be of integer. If you are using the variable of char or float, then the pointer is also should be of char and float. So just basically you have to remember that which type of the variable you are declaring. Means the variable which you are declare is of which data type, the same data type pointer should be used. Then so as I had used here n as integer type, so I'll declare my pointer of as integer only. Then so the integer variable, I'll take it as star ptr. Star ptr. Then now I need one more variable to know the usage of the operators. Then to know the usage of the operators, I have to use one more variable. So I'll make it as int x. I take it as int x. So what all we had declared? We had declared three variables. One is n, another one is x, and this one ptr is a pointer variable. Here n and x are the normal variables which will act like an operand now with the operators like your address of operator and pointer operator, and here ptr is your pointer variable. How to know ptr is a pointer variable? Because to the precedence we have used the asterisk symbol, that is your pointer operator has been used. So we'll consider ptr as a pointer variable. Done. Now the declaration is over. Now we'll start initialization so that we can see the usage of each operators. How we can use both the operators, we'll see it. So what I'll do is I assign some values now. N is equals to 50. I'll assign n is equals to 50. Now what I assign, the next is ptr is equals to ampersand of n. So what both will give you the meaning? We know n equals to 50 means the value 50 is assigned in n. Now in n 50 is stored. Next, ptr is equals to the address of operator and n. Ptr is equals to the address of operator n. This means the address of n is stored in your ptr variable. The address of n is stored in your ptr variable. Next, what I do is x is equals to star ptr. X is equals to star ptr. What it means that in asterisk ptr, that is in ptr, what you have stored, in that what value is there, that you have to assign to x. I'll explain it when we trace the program. That time we'll see what exactly these three lines means. Then so let me continue with the next lines and I'll just finish the writing program and we'll see at the execution time what will happen. Done. So cout, I'll just print the value of all the three variables. Cout, value of n is n, endl, cout, value of pointer. What is the value of pointer? Which will be there in your ptr, endl. Next, cout, value of x. Value of n is printed, value of pointer is printed. Now value of x. Value of x, which is there in x, endl. Now I'll close, get ch and close the main function. Done. Now we'll try to execute this program. When the program is executed, main function is there. There is no any classes and objects. So directly come here. Let me write clear screen. Okay. The screen will be clear. Your output screen is ready now. Then now int n. What it means? Int n means in memory for n you reserve the space. In memory, int n means it will informing. We are informing to the compiler that in your memory location for n 2 bytes of the memory you reserve. 2 bytes, why? Because int is of 2 bytes capacity. So consider this is your memory address loop. Okay, so n, here n you store, and its memory address we consider as 100. So of 2 bytes, 101, let me write it roughly. Okay, so these two are for n. These two are for n because it is of integer. 100 is 1 byte, 101 is another byte. So 100 and 101 are stored for n now. Done. Now, int star ptr. Int star ptr means consider these two. These are the pointer variable. These are the pointer variable 102 and 103. 102 and 103. So the first one only I'll assign, that is 102. Then next, int x, one more variable we are using. Int x, let me increase the size. This is 106, 107, 108. So from 104, 2 bytes is for x. So what do you mean by int n, int asterisk ptr, int x means there are 3 variables n, ptr and x. You reserve some memory space from your storage. So we have assigned some memory space now. For n, 101, 102. For ptr, 102, 103. For x, 104 and 105. So this much is over now. The execution of these 3 line code is over. Now next line, n is equals to 50. So what you have to do is, in n variable we are storing 50. So here in n we are storing 50. Here in n we are storing 50. Next line, ptr is equals to address of n. ptr is equals to address of n. So here in the ptr, what we have to store? The address of n. What is the address of n? Address of n is 100. So in ptr you store 100. In ptr what we have to store? We have to store 100. Then next line, x is equals to star ptr. That is, x is equals to pointer variable ptr. So what we are storing now in x? In x, we are not storing the address of ptr. In x, x is equals to star ptr means go to ptr variable. In ptr, what is stored? The address of n. And in address of n, what is stored? 50. The 50 is stored back in x. So what it says, what we have, the meaning of your star ptr, it returns the value of a variable located at the address specified by its operand. That means here the star ptr, this is for 100. So 100 is a memory address. So what is there in this 100 memory address? 50 is there. So 50 you store in x. Then what we have to do is, in x we are storing the operand. Star ptr is to which memory address it is referring. So what is there in its address? 50 variable is there. So we are storing this 50 back in your x. Then, so we always store in x the value which is there in the address which is there in your pointer, that value we store it. Then, so that what means of this line, your x is equals to the pointer operator and the variable pointer. So what we are doing, simply in x is assigned to your pointer variable. We go to pointer variable. What is there in your pointer variable? The address of n. And now we go to address of n, that is to 100. And in this address, what is stored? 50. Bring that 50 back and store in your x. So just simply we are saying that in your pointer variable, the pointer variable is referring to what address, and in that address what is there, that value we have to store in your x. Done? So these 3 lines are executed. Now in n, 50 is there, in ptr 100 is there, and in x 50 is there. Then, so when we execute, means we are printing these values, right? Then, so first see out, the value of n is written. Sorry, this is your output. The value of n. So what is the value of n? In n, 50 is stored, so 50 is printed here. 50 is printed. Coming to the next line, value of pointer. Value of pointer, Now what is there in PTR? PTR 100 is stored, so 100 is printed. Actually, generally we had taken here as 100, but in compiler, in actual computer, it will be some hexadecimal numbers. That value will be printed. For your understanding purpose, I had referred these values, but initially the storage value will be in the hexadecimal values and those will be different only. Done? So here 100 is stored. Next, coming to the third line, the value of x. Value of x. So what is there in your x? X is initialized to your pointer variable. Come to pointer, in that 100 is there, but 100 initialized to again 50. So in x 50 is there, 50 will be printed. Done? So like this program will be executed. So how we use this address of operator and pointer of operator, we have to understand. Done? So in today's session, I had covered 2 points, that is the operators of your pointers. Which are the operators we are using? Address of operator and pointer variable. Pointer operator. Both are your unary operator. One is used to deal with your address, another is used to deal with the pointer variable. So both how we are initialized, we are seen with the example. If you have any doubts relating to today's class, ask me. The other points relating to your pointer chapter we'll study in the next class. Thank you.